We're looking at balancing equation, a very important part of chemical equations. So to understand this, we'll start off with something called a skeleton chemical equation. In a skeleton chemical equation, let me take an example. CH4, your methane reacts with oxygen to give out what? Carbon plus water. This is an example of skeleton chemical equation. Now, let me do one thing. Let me actually draw a table, a small table. Herein, I'm going to represent your reactants, and herein, I'm going to talk about your product. What exactly? I'm going to list all the things that is involved in the reaction. So, in reactants, we have carbon, hydrogen, oxygen, right? And in product 2, carbon, hydrogen, oxygen. So sometimes I might talk about reactant as LHS, and this is your RHS. LHS stands for your left hand side. So this is your LHS and this is your RHS. Now on the LHS we have carbon, hydrogen, oxygen. On RHS also carbon, hydrogen, oxygen. Now what is that specifically looking at is number of carbon atoms. So if you have seen the basic videos, and you should have actually, what does CH4 represent? Let me just talk about CH4, right? Not on CH4. What does it mean? It is talking about a compound which is made up of a compound made up of one carbon atom and 4 hydrogen atoms. Right? That's what it talks about. CH4. That's what it means. So if this is carbon, right, you have hydrogen, 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 hydrogen. It's in this manner, for example. Okay. I hope you guys remember this, and please do watch basics before watching any critical part. Now let's have a count, right? We're just counting. Carbon, there is 1. Hydrogen, there is 4. Oxygen, there is 2 of it. On the right hand side, carbon, there is 1. Hydrogen, there is 2. And oxygen, there is 2 plus 1, right? This is 1. If nothing is written, it's 1. So in total, it is 3 of it. So is this okay? So what is the big deal? Here, if you see, 4 hydrogen became 2, while 2 oxygen became 3. How is that possible? We have seen that under normal condition, we can't have this. That is, we are violating, what is that we are violating? Which law? The law of, again, all of this we have spoken directly, indirectly in our basics. Yes, conservation of mass. Atoms cannot be created nor destroyed in our normal setup. So this violates law of conservation of mass. Things cannot just disappear and things cannot just appear. So what is the solution? Well, the solution is this. Same thing. Okay. This is known as balancing. That is, if I make this as 2 and if I make this as 2 over here, it becomes balanced equation. This is known as balanced equation. Let's look at it. Let's analyze this. Carbon, there is 1. Hydrogen, there is 4. And oxygen, there is 4. On the right hand side, carbon, there is 1. Oxygen, there is 2 and also 2 over here. So basically, there is 4. And hydrogen, there is 4. So can you see that? The number of molecules and atoms on the LHS is equal to number of atoms on the RHS. It maps. Herein there is no violation of law of conservation of mass. And this is an example of your balanced chemical equation. So what is a balanced chemical equation? It is a scenario wherein you have the number of atoms in each element is same on both the sides of reactants and product, right? So basically the number of atoms are same on both ends. When I tell both ends, it is to do with your reactants and product. Does it make sense? A quick note for people who didn't understand what is this 2 times of H2O. Let me go to that. Put on 2 times of H2O. Herein we have a compound made up of 2 times of 2, that is 4 hydrogen atoms and 2 oxygen atoms. Let me explain this way. See, what is not hydrogen, oxygen. What is water made up of? We have oxygen and the hydrogen are attached in this way, right? But there are 2 of it. So there is not 1, there are 2 of it. There are 2 of it. Okay, that's what this 2 represents. This coefficient represents that. So hydrogen, we have 2, this is hydrogen, this is hydrogen, this is hydrogen, hydrogen. How many are there in total? 4. While this is oxygen and this is oxygen. So how many oxygen are there? There are 2. Let's come back to this example. This is carbon. There is 1 hydrogen, 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 hydrogen. Overall there is 4 hydrogen. But there is only 1 of it, 1 times of CH4. But when I tell 2 times of H2O means what? There are 2 of those. Okay. Again, understand the coefficients, understand what is this O2, CH4 mean. All of this is done in basics, but I'm just revising. But yeah, please watch the basics and then only move forward. So herein it violates, herein the number of atoms are same on both the sides. So it does not violate, right? It does not violate the law of conservation of mass.